Todd Danielson here, the editorial director of Informed Infrastructure at the 2025 Year in Infrastructure event for Bentley Systems in Amsterdam. Now I'm with Brad Johnson.
I've been in technology for 25 years and utilities for about 15. And that first 10 years was spent on the technology side as a systems administrator working in data centers in the 2000s. And so it's interesting to see that past part of my career now meeting up with my current things and helping to combine those two to help, say, these large load customers come online into the grid in an orderly way, which is something our user community is constantly working to accomplish. So it's kind of fun to take that, past civil and past structural and blend that experience into how it's intersecting with power.
Sure. Why don't you, since you brought it up, can you kind of describe that timeline of how things maybe were done back in the day, how they're kind of being done, and then maybe even how you think that they should be done in an optimal world?
Yeah. So, back then, data centers, were large consumers of energy, but we're typically just connected to the distribution system, or in some rare cases, some of the lower voltage transmission systems. And so, we were used to building large warehouses, and so you had to build them nice and tight and energy efficient, et cetera. So it was pretty typical. Now data centers are massive campuses requiring transmission level energy delivery. So these are huge civil projects. The structures that support them are massive structural analysis projects, things you might use like a PLS CAD for to bring the transmission line in. And so the scale is now bringing more disciplines together. So it's driving more cross-engineering disciplinary collaboration than we used to have to do. It used to be, distribution would deliver this much three-phase power, multi-path for reliability, and now it's transmission planning and grid planning involved for a single data center site. So how is it working well, and what maybe could they be doing better? I think it's working pretty well, given how fast things are changing. Think of the last 140 years of engineering around power. I don't know that it's ever moved this fast. So the industry's doing a pretty good job of keeping up. What could they do better is just adopting the technologies that drive that cross-disciplinary collaboration. That is so key to keeping up with and maybe even getting a little bit ahead of the demand that's being put on the grid.
More specifically about what those cross-technologies are, should be, just so they know specifically what to be looking out for.
Yeah, so I'll give you an example, say in the substation. And the substations it's getting interesting because in some cases, the data center developer will own the substation and they'll contract the utility or a construction firm to build it, or the utility will own it and hand off responsibility at the walls of the building. So we now have electric utility structural engineers working with the electrical engineers more efficiently to bring the substations online, not throwing the work packets over the wall at the office from discipline to discipline. So that's one to speed up time to market. And then we're also seeing a bigger integration of traditional building structural engineers and traditional mechanical engineers working with these electric, civil, and electrical engineers, because now we're embedding some of this infrastructure inside these facilities in ways that we hadn't necessarily done. And we saw a couple of examples earlier today in the finalist presentations for the transmission distribution track of how substations specifically are getting embedded in more and more complex environments. So a lot of that electrical, civil, structural, and because of how fast these projects have to get done, that's where the more that they can work in parallel, the better the outcome is, and we get there faster.
Yeah, it makes sense. And in some ways, it's good to have open things because it's just better, but these are literally all being physically put together, so they kind of have to be integrated. Right. Otherwise it's just being ridiculous.
Exactly. Yeah, and if you're designing a structure for its load capacity, shear, snow loading, depending on where it is, et cetera, you might design something that when they go to try to place these large data center components, or say in a manufacturing facility that's electrifying, how do you get them into the building if you haven't considered those non-civil components that have to pass through either during or after construction? So things like synchro, and how do you sequence this to make sure that you're not cutting yourself off from the outside? These are problems that we used to have time to just, we'll take the wall out, we'll put it back. We don't have the time to do these things anymore.
Right. Yeah. So some advice, how can people avoid those kind of problems, and so that they're thinking about these ways? Like, what should they be thinking about as they're starting the designs? And is it seeing all the technology that they have out there, or is there like first steps that they can then see what they need?
Yeah, I think the biggest thing is to have an open mind, is to know that the way that we've done things for 140 years the old ways of doing things aren't going to solve the new problems because of the speed, the complexity, et cetera. So coming to these things with the same curiosity that drew a lot of people to engineering disciplines, bring that to the problem solving, bring that back up again, I think is a key step. And then also be willing to try doing things different ways. Until it's built, there's not a huge consequence to trying something slightly different than you had done before, especially if you're modeling and simulating and testing it beforehand. So, get back to that experimental test and try sort of mindset as well. So I guess it's just readopt the scientific method into the engineering processes. So.
And why is that lost? Because it seems like that would have been a smart thing to do. Is you get used to doing things to get the job done.
Yeah.
And then so you don't experiment. And you're like just trying to get A to B as quickly and efficiently as possible, and don't have time to steer around.
I think it's a couple things. I think it's I think one thing is how fast things are moving. I keep talking about that, but it is really, and it is consistent around the world. We see this in Australia, we see it here, we see it in India with the 2047 initiative. It's just we're moving fast. So, and this is a bit cliche, but we're all too busy running the marathon to stop and tie our shoes. So that I think is a part of it. But I also think there's a lot of comfort and familiarity. And so if you're used to doing something and it has worked, that's comfortable. If I do it this way and I work this way, the outcome will be reliable. Well, it's being tested because we can't either afford the time to do it because our workloads are increasing, or, and this is almost much worse, as professionals move into their well-earned retirement, we don't have an incoming cohort to fill the gap. So, you've heard us talk about AI and automation, and I think you've heard us assert this week, it's not about removing engineers from the process. It's quite the opposite. It's helping the engineers that are at the desk get the best work of their lives done quickly and efficiently without increasing the pressure that everybody's feeling. It's also about filling the desk. So AI used to help fill that gap because we're not going to hire our way out of this problem. So as we bring that new cohort of engineering professionals in, think of the ASE student chapters at universities, think of STEM programs within schools. All of those folks' expectation of technology in their career is being driven by their experience at home. So we have to help use the tools that they expect to be available outside of their engineering discipline as they come in. So how do we attract them, retain them as engineering professionals, and then how do we help the ones who are experienced to free up the time to do the best work and maybe spend a little time helping train that new cohort in.
So one of the things that I've learned here at this event is that in the engineering industry, which is usually slow to adopt technology, they're actually pretty quick on AI.
Yeah.
Their curve is much faster than it traditionally has been from I've seen.
Yeah.
Is that because of younger people? Is it because of the exposure to AI now, or is it just because it's that much better than what they're doing, and there's not enough people to do it, and it's like mandatory almost?
I think it's actually I keep saying it's all these things, because it's like anything in engineering. It's never just one force. It's like multiple different forces, shear and lateral, et cetera. I think it's a couple things. One, utilities love fast follower, but they don't always love to be first. Luckily, there have been some innovative fast movers in this space that have shown that you can responsibly and reliably integrate AI into your work processes without introducing unnecessary risk. So we've had the first movers, and they've gone, and now the rest of the industry is saying, wow, we want the same benefits. We want those cross-checks and that speed of work and creating efficiencies without duplicate entry. I mean, engineers hate duplicate entry. It's the most annoying thing, right? It's inefficient. So they see that and they say, well, somebody went first, now I want to come fast second. So we have that happening now. And the first movers, they did it because either they just have an innovative mindset at the heart of their work, that's just a part of their company culture, or they were forced into it because of demand or something like that. Or perhaps a leadership change happened where somebody said, we need to do things different, and we need to look at this. So I think that's the other part of it. And then, of course, at the end, it's the same thing we always hear. Crushing new demand coming on the grid. We got to get this work done. Everybody's depending on it. And I think that's a big part of it. And it's not just financial. I think it's also the fact that engineers feel a sense of duty because of the work that we all do directly impacts quality of life. We have it pretty good that in most places in the developed world, people could take for granted that you throw the light switch, the lights are going to come on. And we're on the ragged edge that if we don't keep up, that's going to be a lost safe assumption at some point. So I think engineers feel incentivized and inspired to do this best work and look for any tools that aren't too risky and can help them get the work done.
So I'd imagine that most, all the engineers, that the tools that they have, like their latest upgrades will have the AI, but maybe if they don't have those latest upgrades, what are some ways to maybe like to try them out or to convince leadership that these work and should actually get these upgrades?
Yeah, it's a great question. I think it's a few things. One, I think looking at your peer group for examples of success, so that if you're working up into your organization, working to help inspire them to be willing to take a risk or to try something new, point out that you're not the first mover, you're the fast follower. I also think coming up with very practical outcomes that come from using this. It's not AI for AI's sake, and we're not generating a bunch of AI slop in the process. I think it's really important. So showing that it has a tangible, important benefit to doing it can help inspire that support. And the other side is experiment. While you may not have that tool deployed across your entire enterprise, you might have a few projects that could benefit from trying it out, maybe a low risk or a low work. If it's a substation, maybe it's just a small little distribution substation and not the biggest one in your entire system.
Sure.
So starting small. And if that's not even possible, I think start incorporating data governance and data curation in your existing engineering processes. Because all these automation technologies, AI, et cetera, they all depend on good data. And in the engineering process, we are generating tons of data. And unfortunately, as I was saying earlier, it's a capital asset. It's usually a stranded asset. And if you talk to the finance folks, they hate stranded assets. So this is a chance for engineers to help the finance folks, which is a wonderful thing.
What specifically might that look like? How can they verify that data and work with the ways that you were talking about? Just in a little more detail.
Yeah, I think for one thing, if you're doing designs, embrace 3D. Most engineering tools have 3D capabilities, but they're only being used in a 2D way. It's an Etch-a-Sketch that you're drawing circles, but you're not actually drawing multi-dimensional objects within it. So start there, and then start annotating or start developing these designs in a way that captures that data. That's one. I would also say embracing remote capture sort of technologies is important as well. Most utilities and the engineering firms are already doing reality capture. They're doing photogrammetry, they're doing LiDAR scans. But they're, you saw yesterday the Gaussian splat. I can talk photogrammetry, 4-band cameras, but being able to create those models from the data that exists now is important. So don't throw your data away. So if you're doing capture and you're thinning your LiDAR and you're thinning your photogrammetry, hang on to it. Be a bit of a data hoarder, if you will, because it's become even more valuable as you move forward.
There's new ways to use them now.
Yeah, exactly.
And so I'd imagine that at this event, with all these projects, you probably have a natural focus on the electrical utility entries. Yes. What are some of the new and exciting things that you've seen that they're doing, and what makes them innovative to you?
Yeah, I would say that to me, the things that show innovation to me is that blending of construction planning in the engineering process. So thinking about how a design is impacted by sequencing construction, that to me shows more collaboration, not just within engineering disciplines, but to the partners and colleagues that are into the construction and build phase, and then even the operate phase. So that to me was it's really great to see the collaboration that I talked about earlier, expanding into bigger and bigger groups. So I love that. I love the blending of reality capture data into both brown and greenfield projects. And we've kind of been doing that as an industry for a while, but seeing it being used even more intentionally to sharpen the pencil, if you will, in the design process, I thought that was particularly wonderful. And that these designs leveraging this technology, especially in the case of the Schiphol substation, most of us drove past it and didn't even realize it because it's covered in a greenscape with the proper ventilation at the top. And so engineers are finding ways to integrate this infrastructure in kind of really beautiful ways without being disruptive to the surrounding environment. And they do that because they're designing in 3D. They're looking for those unintended consequences of device placement or things like that. Those are the things that I was watching, just kind of like, this is great. This is so cool.
Who should be leading kind of the integration between construction and building design and the electrical side? Is it the electrical utilities that need to, hey, construction building, how can we work together? Or do you see it coming the other way, or does it should this be everybody? Now that things are just becoming all kind of intertwined to check with all the different departments.
Yeah, I think that it ends up having to be everybody at the table because there is such an interdependence. As we enclose substations in buildings, now utilities getting even more into BIM, but also IFC, ISO 19650. These standards where utilities haven't had a history of having to think about it that way. So there's also kind of the learning collaboration between departments. I think that's a part of it. But I think in the case of like data center development or say electrify like an arc furnace or something like that, I think the utility generally is the best one to lead the process because they have the wider area to develop around. That planning is generally a much larger scale. There's longer lead times. They just need to involve those, say, the site, the building folks earlier on. I mean, for example, if the utility plans to land a 300 kV service here and place a substation there, but the building developer is saying that's actually unsuitable soil site and we're going to use that for fire access, rerouting that may mean acquiring new land, which is expensive and disruptive, right? So there's still that checking in. I think the utilities really have an opportunity to lead the way.
Okay, so if you're the designer, how do you get the utility company that you work for? Like, how do you move that? You know what needs to be done. How do you move that up?
Yeah,
to get the decision made.
I go back to what I said earlier. It's about showing the real value to the enterprise on that. So just take the utility perspective. If you can come to leadership and say that I have a way to use technology that is proven, it's new but it's proven, to help us achieve this outcome, whether it's time to market, how quickly can we get something commissioned in service, cost savings, addressing a labor issue, improving the maintenance and operational costs post go live. That's pretty compelling. But I also think bringing those non-engineering executives into the fold, bringing a senior leader from a utility to an IEEE ST&D show and having them attend those sessions is very powerful.
Okay.
In North America, bringing them to the Edison Electric Institute TDMMA meetings is great because it's the utilities all communicating directly with each other in a safe harbor environment. And I saw it last week. Executives go, I had no idea. If we'd only done this, and they have to see it. Seeing is believing. In Australia, Engineers Australia, we just did a series, 2-week series with them across 4 cities. Engineers in the room, bringing executives with them, decision makers, and then seeing it like, wow, this is actually possible. It just, because we have to remember, these are usually very busy people. It's hard to get meeting times with them. So get them to see and believe. It's like anything, right? Seeing is believing.
Yeah.
So.
No, I believe in that. It's some really, really good, very specific advice, which I love to be able to get. So it wasn't very general. And I know you're busy, so thank you so much for your time today.
Yeah, I appreciate the interview.
Hopefully to learn more about all this, but I'm looking forward to it. Enjoy the rest of your event.
Sounds great. Thank you. Thanks for joining us in Amsterdam.